Hey guys, my name is Tim Schuler. I'm a student in the Industrial Engineering Department, and my project this semester was really to investigate current applications of ontology for malware analysis and malware classification, and then trying to reconcile those into how they would fit into a BFO conformant ontology. So let's dive in. So in this information age, a vast amount of human activity is now taking place online. People are storing more and more information on remote machines that can be accessed over the internet. Data, which can range from banking and financial information, healthcare records that are stored electronically, personal photographs, and information about who we're friends with, are now being stored in the so-called cloud. And the technology is continuing to evolve very rapidly, as you'll see more and more devices become internet capable. But this increased connectedness to the internet creates a tremendous amount of exposure to cyber criminals who employ malicious software or malware. And they do it for a variety of reasons. It could be to damage infrastructure or to steal information like credit cards or passwords, or to encrypt data held either on your PC or at institutions and then demand a ransom payment for that data to be unencrypted. And so millions and millions of dollars have already been spent to help defend against and remove malware. And the cost only seems like it's only going to grow. Combating malware can be very difficult, and it's certainly not trivial because malware can evolve on a daily basis. So just as security professionals are patching one hole to defend against yesterday's malware, a new variant has already emerged on the scene that needs to be defended against. So one particular challenge in malware analysis is that cybersecurity professionals may have very different understandings and use different terms to describe the same piece of malware. And this paper that I have quoted here also highlights that a lot of the automated analysis tools can have different representations of malware too. So all this makes integration very difficult, but it also suggests that ontology could have tremendous applications for malware analysis. Now, to give you an overview of my project this semester, I first simply wanted to start out reviewing the literature on applying semantic technology, and in particular using ontologies to address this challenge in malware analysis. And it turns out a lot of the papers were more broadly applied to the field of cybersecurity in general. Next, I wanted to dive a little deeper into what malware actually is and how you provide an adequate ontological description of malware. And then finally, I present a very initial proposal for how a malware ontology could be made Buffo conformant and extend BFO. Early on in my research, I came across the malware attribute enumeration and characterization language, or MIC for short. I should note that MIC is not an ontology. It's really a set of XML schemas that tries to address the challenge of a lack of standardization by providing a controlled vocabulary for describing malware behavior. So even though MIC is not an ontology, it does offer a store of terms and definitions that could be incorporated into an ontology. The same corporation that developed MIC also submitted a white paper for a vast ontology of the cybersecurity domain. This proposed ontology would also include a sub-ontology dealing with malware. So the white paper basically put forward a set of resources and how these could be used in building the proposed ontology. And I have to say the scope of this ontology is massive. It imports terms for geospatial information, time, persons, so that you can describe threat actors, like I said, malware, and also terms dealing with the hardware and the network infrastructure. So this initiative seemed very promising in terms of how one might go about building a malware ontology. But unfortunately, I couldn't find any subsequent papers describing the status of this project. I even reached out to the principal investigator of this project, and he indicated that just due to contracting reasons, information on the project was not publicly available. I decided to review one of the more recent ontology papers I could find, and I came across the malware behavior ontology, which is an ontology that takes kind of a different approach than you might expect when building a malware ontology. So the paper kind of highlights that modern malware is far too complex to be sorted into traditional categories like viruses, worms, Trojan horses. So rather, this paper attempts to describe malware behaviors in terms of the source programs, the target objects, and the processes that the sources do on the targets. And so they use the semantic web rule language to develop rules that can classify these events into suspicious behaviors. This is just a closer look at what can be a suspicious behavior in the malware behavior ontology, but we'll come back to that in a bit. So while the MBO does take a pretty cool and interesting approach in terms of describing malware in terms of its behavior and the actions that it takes and what it targets and what the source is, closer analysis of the ontology kind of reveals that it doesn't always follow best practices in ontology development, particularly those outlined by the Obo Foundry and the textbook on basic formal ontology. So the first thing that I want to point out is that when I imported this ontology into Protege, there were no textual definitions for any of the terms. So anything that was ambiguous to the ontology user stayed that way because none of the terms were defined. I'd also like to point out here that the MBO uses asserted multi-inheritance, which is generally not recommended. It's recommended that single inheritance is used in ontology development, and then multi-inheritance can be inferred by using a reasoner. So the third thing that I want you to notice in what I have highlighted here is that all of these terms exist independently of whether or not they're targeted by malware. So one thing that I realized upon analyzing this ontology is that target is something that is determined externally from whatever object is being targeted. In other words, target is being determined by the malware. So it suggests that it's something that's externally designated from the target object, and so it leads me to believe that target is actually a role. And so diving deeper down into the suspicious behavior component of MBO, there's several classifications here that simply don't hold up. You have relations like binary file is a get command, email sending is an attack launching event. I mean, most of the time when I send emails, I'm not launching a cyber attack. Browsers and operating systems exist outside of subversion events. And I mean, a browser is not an event. An operating system is not an event. So there's definitely a lot of inconsistent classifications going on in this ontology. So part of this research project was to begin development of a Buffo-conformant ontology that provided an adequate set of terms and definitions that could help malware analysts and cybersecurity professionals describe and reason about their data. This new ontology would also utilize the information artifact ontology, which is also Buffo-conformant and has useful terms like software, programming language, algorithm, and plan specification. So the resulting malware ontology would extend both Buffo and the IAO. One of the things that I noticed during my literature review of existing ontologies for malware analysis was that none of them provided a good reference of what software actually is. Because at the end of the day, malware is maliciously purposed software. So one of the preliminary steps that I wanted to take in proposing a new ontology for malware was to actually understand ontologically what software is. After that, I wanted to identify what Buffo terms could be imported into the ontology and how they could be extended, and similarly for the information artifact ontology as well. The best definition of software that I found is provided in this paper by William Duncan, and Duncan describes software as a specification, and when it is concretized, it bears a normative role over the hardware it is encoded on. So concretize is an important relation in the information artifact ontology, and in the context of software, it captures that a generically dependent continuant software has been encoded or installed on some device. So concretized software basically means that the software has been installed or that it's runnable. Normative role implies that the software has kind of a particular say in determining how the hardware behaves. Basically, it provides the instructions that tells the hardware to do a particular set of computations. One of the most important Buffo terms needed in the new malware ontology architecture is generically dependent continuant. So malware entities are encoded in some bearer entity, but malware doesn't specifically depend on any particular bearer. Rather, the fact that malware can be encoded on several different artifacts and the fact that it can be copied suggests that it is some kind of generically dependent continuant. So from the information artifact ontology, I borrowed the term software and used that to basically build out what malware actually is. One of the problems that I encountered in this project is what I refer to as a software contextualization problem. And what I mean by that is basically depending on the context in which software is used, it could be considered part of malware or it might be considered completely benign. As an example, as a software developer, there's often instances where I might have a script that contains a command that disables the firewall on some computer. This could be for integration testing, like I'm trying to get two machines to communicate with each other, so I need to temporarily disable their firewalls so that they can exchange messages. But at the same time, that same script could be used by malicious software. And so the issue is that the same exact piece of software, depending on the context, might be malware or it might not be. To solve the software contextualization problem, the role of threat actors and their use of the software has to be accounted for. So basically, software can become malware based on the malicious intent of the threat actor. So this slide basically captures a few of the terms that I have introduced by extending Buffalo and the information artifact ontology. And I won't go through all the definitions, but I just want to highlight my definition for malware. I define malware as a type of software that is used by threat actors with malicious intent during a cyber attack. I define cyber attack as a planned process in which malware is utilized by some threat actor to access, damage, or obtain information from a malware target. I define threat actor as a role inhering in a person or group of people that is realized when the bearer plans a cyber attack or participates in a cyber attack. And so the rest of the definitions are found in my paper, but I just wanted to highlight a few of those. This basically shows a few more of the terms that I introduced to help describe keyloggers. So keylogging spyware is a type of information stealing malware, which is a type of malware. It has keystroke logging software, of which PyHook is an instance, and I also introduce terms that could describe the Python implementation of PyHook. So I would like to continue to work on this project. Future work would include developing a better description of what malicious intent is and what it means for threat actors who use malware in cyber attacks. I would like to continue to add terminology from Mike to capture more malware behaviors. And finally, I would like to test the ontology with real data from malware analysis and see if it actually works. Thanks.